correct fields that your adaptive function needs using widgets. So please submit the UI harness file as well as the pictures of your action cards on the UI harness. So, to start off, let's just yarn start. Probably should have done this before, but this will take a couple seconds here. And the whole point of this quest was, in the previous days, we've been working with contracts, transactions, scripts, and the daplib. And so this is really like the final step, right? We have, all our stuff working in the code, and we just want a way to execute these transactions and scripts using our daplib, but, with some sort of client or front end to help us out. So this is what we're going to be doing today. All right, so we have it loaded up here. This is what it looks like from previous days. Also, there was a request to make the font size bigger. I'm glad I just remembered that. Hopefully this will help. So let's kind of scroll through here and see what we had to do. So we did all of day 3 yesterday in office hours, and today we're doing day 4 stuff. And you'll see that if you scroll down here, there's a bunch of nulls, right? There's null here, there's null here, null here. So these are the action cards I wanted you to do. Now, if you click, view, nothing's going to happen because it's not tied to anything yet. And you'll understand that if you've been through the day 4 content. So before we do this, let's just set up our DApp by, setting up accounts. We'll set up the admin and Alice account like we do in previous office hours. We'll check to make sure the setup works by getting the balance of kibble for the admin and Alice, get the total supply. Let's mint just 100 into the ecosystem here, into the admin account. Let's just make sure all these are working. Let's transfer 50 into Alice's account. And this is all just from previous day stuff, which is why I'm going pretty quickly. You can see all the transactions and scripts are working. So let's go to day 3, which is with Kitty items. Let's set up these 2 accounts, admin and Alice again. And we're doing this because in the day 4 stuff with the marketplace, both these accounts have to be set up with Kibble and Kitty items to be able to buy and sell stuff from each other. So we'll mint, a Kitty item into Alice's account. Let's mint another one of, type 7. And then maybe we'll mint another one into Alice of also type 7, just random. All right. So then day 3, which is, let's just skip the transfer step. Let's read the collection. Let's read the collection IDs from the admin and Alice. Cool. So 0, 1, 2 is expected. These are just the IDs, the NFTs, not the type ID, but the item ID. Read the collection length. This should, be similar to what we did yesterday. Let's just, for example, run this for the admin account. Okay, this is what we're expecting. And lastly, the total items. So now we're on to, new stuff. So this is day 4, Kitty items market. Now, there's some stuff that's already set up for us. So let's set up the admin account for Kitty items market. Let's give the admin account the ability to set up a marketplace in their own collection. So that transaction goes through, we see the gold star. And then we get to something where it's like, okay, what do we do, right? So if we go to our UI harness, which is in packages, client, right here, source, harness, and then fast forward harness, I scroll down to where it said day 4, and we have a bunch of action cards already set up. So you'll see that this one, which is the setup account, is already set up, which is why that worked. And then we get to this, right? So this is the day 4 Kitty items market sell market item. And there's nothing here, right? Which is why it says null. So in order to implement this, we were learning about account widgets, text widgets, what all of these attributes mean. And so let's go through that together using the README. Now I'll just pull this up right here so that we can see it together. So let's scroll down a bit and let's look at what I wrote in the README. So an action card element has 5 HTML attributes. First one is a title. This is the text on the top of your action card and represents the title of it. So this right here. And this is, this title. So we've already really implemented this for our action card. And for all the action cards you had to write, I already gave you the title. So you'll see that I already gave you the title right here. Now let's look at the next thing we need to do. So description. This is the text on the bottom of your action card that provides a simple description of what it does. So pretty self-explanatory, but this is like where the description is right here. So let's add a description. We'll say description equals this action card sells a kitty item, right? So we'll save that. And, it might not, okay, so yeah, so the description shows up, sweet. Now the next part is action. So this is the name of the JavaScript function in your dapplib that this action card will call, and method, either post for transactions or get for scripts. So let's do these two together in conjunction. So let's try and figure out which dapplib function we want to call. Now this, you're really supposed to be getting this from the hint that, this is day 4 kitty items market, sell market item. And let's go to our dapplib in order to find the function we want to call. So let me close out all of these, open our dapplib, and let's just search. So let's search for kitty items market. All right, let's scroll a bit. This is buy market item. That's not the one we're looking for. This is remove market item. That's not the one we're looking for. This is sell market item. So perfect. We found our target here. So the question is, well, actually we'll get to that in a second, but this is the function we want to call. So it's this is going to go in our HTML attribute for the action. And this seems to be a transaction, right? Because it's blockchain.post. So we're going to put, I'll put this on a new line. We're going to put action equals kitty items market, sell market item. And, this is a very lengthy name, but I only did that to make it make more sense. But, in your own dApps, you don't have to write a crazy name like this. And then the method is going to be post. And what's the last thing? So fields, all of the fields we will pass into our JavaScript function in our dapplib. Each field will be mapped to a widget, which I'll explain in the next section. So we'll get to that. And you will access these fields in your dapplib using data.name of field, right? So this is really a hint for our dapplib, but we've already conquered that yesterday. So let's try and figure out what to put in our fields attribute. So if we go to our dapplib, you'll see what stuff are we getting from our client here, right? We're getting data.signer. And remember, this data object is always coming from the client. So we have a data.signer, a data.item ID, and a data.price. So we have to make sure that we're supplying this to our dapplib, right? So a signer, an item ID, and a price. So a signer, an item ID, and a price. And you have to make sure that these names match what we put in here, because this is how it's getting these fields. All right. So in the README, I wrote that each of these fields is getting, mapped to a widget. So let's try and, figure out what widgets we want to use in order to, pass these in. So I also should probably pull up the Discord on the side so I can read any questions we have along the way. Okay, so we have a data.signer. Now, what is this, right? This isn't like a number. This isn't, anything fancy. This is just an address, right? It's the person that's signing this transaction. So we have two real options that I put in the README. Now, there's a bunch of widgets in DappStarter, and you can actually see them by, if you go to your client and then go to, I think it's components. Yeah. If you go to the components directory, you'll see all the different widgets we have. So we have an account widget, a number widget, a switch widget, all this stuff. But from my experience on DappStarter, the two that I pretty much always use is account widget and text widget. So let's see between these two, which one would be the most helpful. And, the obvious answer is that if this is an address, it's the account widget. So let's add an account widget. And oftentimes I just, will pull from stuff like this. So, I'll actually write it out just for the sake of the office hours. So it's account widget. And the field has to map to what we put here. So this is, a signer. And the label is just going to be, what appears next to the account widget. So we'll just put signer in all caps. With capital S, and this will be our account widget. Cool. So this is good for this one field. Now the next one is an item ID. Now this doesn't make sense to me in an account widget, right? Because this is just a number. So let's put a text widget. So a text widget. The field is item ID. The label will also just put as item ID, and the placeholder is where I like to put maybe like an example of what we would put here. So let's just put like 0, because that's an example of what we would place in this text widget. Then lastly, we have a price, and this is very similar to the item ID, where it doesn't make sense for this to be an address. So we're gonna have to type in our price, And let's just do it like this. So placeholder, and I'd like to put, I don't know, maybe like 30.0 or something. All right. So we have hopefully set up our action card to work, and let's see if this will go through. So it'll recompile for us. I think it already did. So let's scroll down and find this action card we just set up. So here we go. Sell market item. Now before this was null. And look at this. It already sets all of it up for us, which is super awesome. So let's sell something, right? If we go to our admin collection, our admin has 0 and 1 ID'd kitty items in its collection. So let's just put, I don't know, 0 up for sale. Or that's right here. Let's put 0 up for sale from the admin. And the price will be, let's say 15. And let's see what happens. Submit. And the transaction goes through. Now, the reason it went through is because I already set up the transaction and daplib function for you, as we saw. But it's super cool how we could set up our action card really fast and simple, like we did, So let's just make sure that it's actually, being sold. We haven't set up this yet, but if we, read the sale collection length for the admin, we should see 1, right? Because there's 1 kitty item up for sale. Sweet. So let's test this one. Let's remove market item. So let's just take that one right back down. So it's the admin signing it for the admin's market collection address. We're taking down 0. Let's just submit this. And we should see that, it goes back down to 0. All right. But let's just resell it for our purposes, right? So we just resold the read sale collection IDs. So this is a very similar process where, we're just going to be figuring out what stuff to put in our, attributes and what widgets to use. So let's just do the same thing. The description, this action card buys a kitty item. The action is, let's go to our daplib. Kitty items market by market item. So we'll copy and paste that. Then it has a method, and this is a transaction. And the fields, well, let's look at what we need. We have a data.signer, an item ID, and a market collection address. So this is probably going to be an account widget. This is going to be a text widget, and this will be an account widget because this is an address. So, just to show how quick this can be, like let's just put signer item ID and then market collection address. So just to show how quick this can be, let's just, literally copy what we put up here, both the signer and the item ID. We put it in here, and then all we need now is one more account widget called market collection address. And we'll put in here market collection address, and let's save. And we should see our fully working action card. So let's go all the way down. And sure enough, our buy market item action card is fully set up. And also for the label, like this label that I'm putting here, the market collection address, this is what appears, as a label for the account widget, and the label for the text widget is right here. All right, let's do it. So let's have the admin buy item ID of 0 from admin. Let's buy. Let's see what happens. Transaction executed. Let's read the sale collection length of the admin. It should be 0 because we just sold it. So there's nothing left. Let's go to the let's go to see if the Alice account actually has the kitty item. Boom, Alice now has 0. And let's make sure that the price was also taken into account. So let's get the balance of the admin and Alice. And remember we set them up both with 50. And now one is 65 and one is 35 because the price was 15. Sweet. So then there's one more action card to implement. And this is going to be the read sale collection IDs. Now this one's a little different because it is a spoiler, it's a script. And this one says it's kitty items market, read sale collection IDs. Awesome, let's go find that in our daplib. So kitty items market, read sale collection IDs. We're going to assume it's this one. So let's do description equals this action card gets all the kitty item IDs. Let's make the action equal to the name of that adaptive function, method equals get, because it's a script, and the fields are, well, what do we need? We need one thing, a data.market collection address. So we can just scroll up. Oh, we find that right here. Let's just copy and paste that in. Take the market collection address field, put it in our fields HTML attribute, and we're done. Unless I just types. Okay, yeah, and we're done. Let's go back and see this in action. And right here, sure enough, read sale collection IDs. It doesn't help that we just sold it, but there's nothing in both accounts. Well, we haven't. Oh yeah, so the reason we get an error for Alice here is because we haven't set up Alice for the market. So I'm glad we ran into that. But yeah, for the Alice, there's nothing in here because we just sold it. So there should be nothing left. Now, if we went up here and I don't know, resold an item. So Alice, the admin still has one. Let's just sell it for like 100 or something. Submit this. Transaction goes through. If we scroll down, you'll see that the admin is now selling kitty item with ID 1. So this concludes, if you're able to do all of this, that concludes the week 2 quest 6, where we were learning how to implement action cards. Are there any questions about that?
Jacob, if you wouldn't mind going back to the source code, since a lot of the people who will be going over this will be going over the video, they might have a question about the components we are using here and the widgets in particular. I'd just like to point out that the widgets are just syntactic sugar. They are essentially wrapper HTML components for your built-in HTML components. You should not feel any pressure to use them as is, but if you do, they're a convenience. Specifically, let's go to line 154 where we have the text widget. You are not required to use that. That's just an input field. You can swap it out with a standard input field by typing input, the input tag, and just saying data dash field equals item ID. And Jacob, if you don't mind doing that. Sure. So what the widgets do is essentially give you like the whole label and the formatting and all of that kind of stuff. But if you get rid of your text widget and you use this instead, you will see that the behavior of this is unchanged. So you'll want to get rid of the text widget, otherwise it'll collide because of the two fields being named the same. Yeah, so it will work just the same, except it will not be a pretty formatted field, which we'll see here momentarily. So it's, it's right literally here, there, and it's just not. So whatever the item ID you would want to put in there is what you should put. So you would normally put like a 1 or something, right? The ID of the item.
Oh, you want to actually do it?
Yeah, like actually run the transaction to show that it works just fine with. Oh,
it's because we don't have enough balance. Wait,
okay.
Let me mint 100 into the Alice account.
Okay. But yeah, so the widgets are web components. They're syntactic sugar for HTML. Yep. And it works just, the key is to take advantage of the fact that HTML attributes have built-in capability for using data dash attributes to for data fields. So that's basically what it's leveraging there. So you can do that with any HTML element that has a value property. So I believe that goes for almost every form element. So when you use the action cards, you can do that. Now in reality, you're not in your app, probably not desirous to use that action card format. So if you go back to the UI here, Jacob, I just want to address one other thing. The actual web page, please.
Oh,
yeah. So the action card is itself just a pretty wrapper. All the heavy lifting here is done by the action button. So the action button is actually a separate component, and it works exactly the same way with all the parameters, with all the attributes of the action card. And you can place that anywhere in your application. So you can make a pretty UI, with like a nice background graphic and fields and whatnot. and that action button does all the heavy lifting for you. It has just like the action card, a fields property, etc. And as long as you can hydrate the attributes of that action button, so for example, give it what the field names are, it should have what the method should be and all that, the same result it can be achieved. And if you are looking for, well, how does that work? Of course, the source code is there in the components thing. You can see that there's the action button there, and you can see all the properties of it, etc. So they're designed to make your life easier, but you are under no obligation to use it. Remember, one of the best parts about dApp Starter is that client package that Jacob has opened right now. That is there as a convenience for you. You can completely ignore it, delete it, whatever, and add your own app. And the only requirement is, in fact, it's not even a requirement. The only thing you would want to do is import the daplib package. And then you get all the contract bindings, the daplib, blockchain, JS, all of that kind of stuff is automatic. And if you actually scroll down within this package on the left, Jacob, you're probably going to cover it, but in the source, if you go to the dap.js file, there we go. So you can see that it at the very top, it imports daplib. So if you were to not use this, and you had your own JavaScript component or whatever, everything else you see there, like from line 2 all the way to line 10, is unnecessary and only there because we are providing this nicer UI for you. But that line 1 is the only line you need in your application if you decide to create a complete separate package. Of course, then you are responsible for writing all the script for Webpack and all of that kind of stuff. But if you have an existing app or you've got a scaffolding or a skeleton that you like, import daplib and you're good to go. You can ignore all of this. So that was kind of an important point I wanted to make, because sometimes developers are turned off if a platform is too prescriptive. And I just want to make sure that you understand that dApp Starter is not prescriptive in that regard.
Yeah. Thank you, Nick. So yeah, are there any questions about the client/UI harness? And the next thing we'll go over is week 2, quest 7, which is the testing framework.
So asked about RNG breeding resources owning. Is that for today or is that from a previous thing?
Asked about RNG breeding resources, owning resources without defining it in the, well, I'm not sure what you, oh, that's running flow off stars. Okay.
Oh, okay. Oh, I see. Okay. Yeah. Okay. For existing dApp to leverage dApp Starter, you only need to import dap.js. Yeah, I mean, dApp, the daplib, dap.js is the page within the client app in dApp Starter that you would modify. That's the page that says dappiness. If you want an existing dApp to leverage all the dApp Starter stuff, you would import, as Jacob was showing, that one line, and we can copy paste that there, that first line. That's what you want. So you would, and we can actually do this almost in real time, if you will, like create a new folder in here, call it my dApp or something, add your index.js, and then import that line in there. Obviously, you need to do a little bit of work with Babel and all that to make it compile and all that. But line 1, that's all you need. It's daplib.
All right. Sweet. Let's move over to the test. So the test you'll find in packages/daplib/test, then fast forward test. Let's scroll to the top of the file here. Now, what I'm going to do is, before I actually get into the code, let's see what
Jacob, I'm very sorry to interrupt, but when you're scrolling, etc., could you slow down a little bit, because we are also streaming and it just messes up the stream. So if you could
slow
down, I would appreciate that. Thank you.
Yeah. So let's run yarn test, and see what this is even doing. Now you can see what it's doing is it's starting the local emulator. It's creating all of our accounts for us, just like it is on Yarn Start. It will start deploying the contracts for us. So this is very similar to what you'll see with Yarn Start. The only difference is that instead of launching the client or the UI harness, it's going to start running our tests in the fast forward test file. And you'll see it is right here. Signing for account, blah, 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 signing for account. This is running transactions from the test page, and we'll go into why it's doing this and how it's doing this in a second. But see here, like, these are all of our tests, sets up 2 accounts. This ran in 15 seconds, and they're all check marks. They're all going through. And if you go on dApp Starter and you git clone a new dApp, or you download your dApp, these tests are automatically provided for you when you get your foundation. So that's part of the thing that comes with dApp Starter is pre-written tests. So there it is, 15 passing. They're all check marks. This is good. If it failed, we would see a little exclamation mark, and maybe we'll encounter that along the way as we tackle week 2, quest 7. All right, so let's go to our test file. Now there's a bunch of JavaScript in here, but the only real thing that you'll have to change for this quest is these it functions. So it's within our describe function here, and these are all of our tests. So for example, this one sets up 2 accounts, and if we go to our README, actually under the test page, you'll see that there's a section called setting up a test. So let's actually try and figure out what I was talking about here. So we have this one example where it mints cable into the admin account and has the correct balance in the account. And I was saying that in our testing file, what's so awesome about this is that we're using the same functions that are in our dapplib that the client was calling when you would put it in the action attribute. So in order to access them, on the client where you would have your, HTML action attribute and you would put in the dapplib function name, it's similar, but in the testing page, you're just going to put dapplib dot the name of that function and then pass the data object directly. So it's really cool because we don't have to write other JavaScript functions to for our tests. It's the same ones we're using for our client. So if we're running a transaction, we just want to put await and then dapplib dot the name of our function with the data in it. But if it's a script, we're probably calling a script to get some data, and we can just simply set it to a variable and then assert that equal the result of the results field of each of these and check to see if it's what we're expecting. So let's go to our tests and let's scroll down to where we see to do. So this is transfers kibble from admin to user. There's a bunch of tests already written up for us. And here we are. So this is the to do implement this test. And so there's 2 tests for you to implement. And the first one is to remove a kitty item from sale. So in the previous tests, because of the fact that this is all starting from a brand new started emulator, there's no lingering data from our Yarn Start. This is brand new. So if you want to figure out what's kind of going on in these tests, you would have to understand the previous test before and then come to this one. So all I wanted you to do in this test was to follow the guidelines that I wrote out and try and get this test to continue passing. So in our terminal where it says 15 passing, that's actually including the to do ones. It's including this. And it's doing that because it's init function. And so when we implement this, we just want to make sure that it'll stay as 15 passing and not fail. So I wrote, your goal here is to remove a kitty item with item ID equal to 0 from config.account1's sale collection. Then add 2 assert statements that check to see if config.account1's sale collection has the correct length, which is 1, and NFT IDs in it, which is only an item ID of 1. All right, so let's try and figure out how we can do that. Now, the first comment was saying add test data 1 to call kitty items market remove market item. All right, so let test data 1 equal an object. And we don't know what parameters we have to call kitty items market remove market item with. So let's go to our daplib. And where is kitty items market remove market item? Right here. So what's the data that we want to take in here? A data.signer and a data.item ID. So these are the two things we need to pass in our test data object. So let's put a signer. And whose collection are we removing from? Well, we want to remove from config.account at one's sale collection. So we can simply put this, because when they sign it, it'll remove it from their collection. And we're trying to remove a kitty item with item ID equal to 0 from that sale collection. So an item ID, we want to be 0. Sweet. So that takes care of our first step. The second step is to add a test data 2 to call this function. So we want to read. So this one is to remove from our collection. And these two, as we'll see in a second, are scripts that we're going to call. So this one reads the sale collection length, and this one reads sale collection IDs. And the reason we want to do that is because if we're removing a key item from our sale collection, we want to make sure that that happened. So we want to make sure that our sale collection length and sale collection IDs got correctly updated. But first, we have to set up a test data to be able to call these. So let's do that now. So kitty items market read sale collection length. Let's just copy this and search for it in our daplib. Here we are. And this takes in one data field, a market collection address. So we can take this, go back to our test and say market collection address. And the one we're checking is the one we just updated, right? Because if we're removing from config.accounts at 1, we want to make sure we're checking this account's updated data. So we'll put that there. And similarly, this is add data 3 to call kitty items market read sale collection IDs. So let's search for this one, read sale collection IDs. I'm pretty sure it's right here, and it is. And this takes in one data field as well, so market collection address. So we can just simply copy this one and rename it to 3. All right. So our fourth step is to call kitty items market remove market item with test data 1. So if we go to our daplib, which is kitty items market remove market item, this is a transaction because it's blockchain.post. So let's go back to our test and say await daplib dot kitty items market remove market item and pass it test data 1. This will call our transaction. Then we want to call kitty items market read sale collection length with test data 2 and store the result. All right, so let res1 equal daplib dot kitty items market read sale collection length with test data 2. That should take care of our first script. And for our second script, we're going to call this function with test data 3. So we can just simply rename this to res2 and instead call kitty items market read sale collection IDs with test data 3. Okay. Our seventh step is to assert the result from step 5 shows the sale collection has length 1. So let's do assert dot equal res1 dot result. Sorry, I think that just automatically put some stuff there for some reason. And this, we want to make sure it's equal to, has length 1. And the error message, if it's not equal, the third parameter you pass into assert dot equal is what we want to print if it's not equal. So the sale collection length is, I don't know, we'll just say is not 1. Then for our 8th comment, it says assert the result, which is an array from step 6. So let's assert dot equal that res, and this should be, by the way, res1. From step 6 shows the sale collection has an item ID equaled 1 in it at index 0. So res2 dot result is actually going to return an array of all the kitty item IDs that are in this account. And let's actually see why it's doing that. So if we go to our kitty items market read sale collection IDs, you'll see this is returning an array. This is what's being returned. And it's the label that, just to help us out, is it's returning a market collection ID. So it's returning an array filled with the kitty items IDs in it. And I was saying, that we want to check that item ID equal 1 is at index 0. So at index 0 is item ID equal to 1, and otherwise index 0 of sale collection IDs is not 1. All right, let's try and run this test and see if we still get a passing for this test. And while we're running this, let's actually take a look at the next one that we have to do, which is implement this test. This one says it checks both admin and user have correct balances after purchase. So after we purchase from whatever market collection address it may be, we want to make sure that the kibble got correctly transferred between the buyer and the seller as it should, right? So before we do that, let's check back up on our test. Let me try and increase this font size so that it appears okay on the video. Hopefully this is good. And it's very possible that we made a mistake. And honestly, I hope, if we do get an error, we can go over it together. We should see it pop up in a sec. Oh, look, we got an error. So there's no check mark here. So the sale collection length is not 1, expected undefined to equal 1. Okay, well, let's see what's wrong. So this error says the sale collection length is not 1. Okay, so that is this one right here. So what happened? Well, let's try and figure this out together. Let's try and console.log res1 and see what happened. I'm trying to, this is usually how I debug these on my own. Let's make sure that I put all the correct stuff here. So your goal here is to remove a kitty item with item ID equal to 0 from this sale collection. Then add to assert segments to check to see if sale has the correct length, which is right here. And this one as well. We call remove market item. All right, let's.
Jacob, did you intend for line 272 to be the same address?
I did, yeah, because we're checking the collection IDs and the length.
Okay.
So this is, by the way, this is very inefficient. I just did this because I wanted the participants to see like a difference here. But if you were actually writing your test, this is very inefficient code. You would just use test data 2 for both this one and this one. I just wanted to point that out. So these sale collection IDs, yeah, I'm gonna have to console log this one out because I actually don't know what I did wrong here. It could just be a simple error, and honestly, there's a chance that busy. No, okay, yeah. So it's not a simple typo. I know BZ would have corrected me. I honestly, I know I made a silly mistake somewhere.
Yeah, if you don't want to console log, use the debugger at this point.
It's probably because I forgot await.
Yeah, there you go.
Yep, that's probably what it is. We can try and run these tests again. It's probably because I forgot to put await. So it was checking res1 before it was even returned. And then if this doesn't work, then yeah, let's go to the debugger. But I'm glad we're running into this problem, because if you do, then at least you'll know how to get right back on track. And this is called removes a kitty item from sale. So we will try to go back and see what's wrong. Also, just to point out that in this quest, I was basically directly instructing you of what to check for. For example, remove a kitty item with item ID equals 0. And I did this just to make it a little simpler. But I guess it also would have been a good it would have been a good quest to also maybe have you figure out what would have been a good test here. But that will be in today's content, where I want you to actually create your own tests, which will involve a certain level of creativity. So, oh yeah, there it is. So it says removes the kitty item from sale. This worked. So that was the problem. I just forgot to include await. All right, so I'll get rid of our two console logs here. But you can see also that the way that I usually test this is console logging the result, and it actually appears right here, so we can see it. Okay. Sweet. Now the next test was to your goal here is to check that config.account at 0 has a kibble balance of 5 and config.account at 1 has a kibble balance of 25. All right. So add test data 1 to call kibble get balance. Let test data 1 equals. So we're calling kibble get balance. All right. Let's go to our daplib, search kibble get balance. And you'll see this takes in one data field, which is an address. So let's put an address, and we're checking config.accounts at 0. And also, I just want to clarify or sort of review from yesterday's or from day 3 content that config.accounts at 0 is actually reading from dapconfig.json, which is in your source folder, and it's looking at this accounts array right here. So this is also just the direct equivalent. If we're putting config.account at 0, this is the exact same thing. It's just copy and pasting this address. If this is simpler for you, you can totally do it this way. And I'll show you can do it this way by I'll just, put that there just to try it. So this next one says add test data 2. So let test data 2 equals to call kibble get balance. So the same, field config.accounts at 1. And for this one, I'll just use config.accounts to show you it's the same exact thing. Then we're going to call kibble get balance with test data 1 and store the result. So let res1 equal await daplib.kibble get balance with test data 1. Similarly, we want to call this again. Let res2 equals await daplib.kibble get balance with test data 2. And we're going to assert that, after the purchase that happened in one of the tests above, that this will correctly go through and the kibble was transferred. So let's assert dot equal that the result from step 3, so res1 dot result is equals 5. And if not, the address of or the account address, let's put this, doesn't have 5 kibble. And similarly for this one, I'm just going to copy and paste this. The res2 dot result from step 4, which is this one, doesn't have, it should equal 25. And if not, then we're just going to say dapconfig at 1, which is this address. So the address, this one, doesn't have 25 kibble. And this should work. And let's run our test. And if it does, not only does this mean that our tests work, but it also means that, obviously our transaction and scripts are working correctly. And this is one of the things that, Nick was telling me about, where the cool thing about this is that because we're using daplib functions here, we're not only testing our scripts and transactions, or our testing framework as a whole, but we're also at the same exact time testing our daplib, right? Because of the fact that we're using these functions. So if something goes wrong here, well, there's a chance that it's because our daplib function itself was written wrong in our, daplib. And that's just it's perfect because we're testing, almost every layer of dapstarter in one test here. And I'm sure, I'm sure Nick could speak more about that, but that's at least my understanding. So we'll wait for the test to go through. And if it does, then we've successfully completed week 2 quest 7. So it transferred 2 kitty items from the admin to the user. We listed 2 kitty items for sale. We removed a kitty item from sale. We bought a kitty item, checked the admin actually has the kitty item in collection. And our last one that we just wrote checks both the admin and user have correct balances after purchase. Boom, it passed. We see the awesome little check mark, just like the gold star, and we're done. That's week 2 quest 7. Any questions about that? I didn't expect I had to check for typos since you did a fine job finding it out yourself. Yeah.
So if there's not any questions, I wanted to discuss the architecture a little bit to add a little bit of color to the implementation you've done here. So I'm going to actually post a couple of links here in the Discord. So what we use for the testing framework is Mocha.js. So that's a very popular JavaScript testing framework. And we use the chai assertion framework. Now, if you look at a lot of the assertions that Jacob has been using, they're basically equal. But in a lot of cases, you want something more sophisticated depending on the dApp you're building. You want to do less than, equals, greater than, all those kind of things. So please refer to the chai assertion library and the documentation, which is pretty sweet for all those variants that you can find. Now, taking a little step back, we wanted to make sure that when we built out the dApp Starter project architecture, that testing was a first-class citizen. I cannot emphasize to you how important it is to have unit testing for your dApp. In Web 2.0 apps, etc., it's usually optional, except for when there's money involved. But with decentralized applications, this is not an option. You have to write up your unit tests for a couple of reasons. One, in general, most of the dApps that do anything useful involve money, and when it's things like tokens, etc., and the fact that there is no fallback, like with a credit card on Web 2, you could call your credit card provider, you can get a refund, you can dispute a charge, etc. Here, there is nothing. So you're going to have very unhappy users if you haven't tested this thoroughly, especially for edge conditions. Edge conditions is typically where dApps fail. So make sure you test for those. Units are a big deal. You might be multiplying, by 10, but instead there might be a bug somewhere where it's multiplying by 100, and all of a sudden you've cost people a lot of money. And when you read about all these, applications or contracts having problems, etc., granted, a lot of them are exhaustively tested, but I cannot emphasize, if there's one takeaway you take from this whole bootcamp, it is test your smart contracts. Now, we make it really easy for you by allowing you to test the full stack. In other scenarios, what you may have to do is you test your client UI separately, you test your API separately, and you test your smart contracts separately. By routing everything through a single library, dapplib, we make it possible for you to test your full stack at one shot. So that saves you a ton of time. So even if you're adding an API, make it go route through dapplib, your client interactions, everything go through dapplib. So at that point, you're really left with testing sort of the user experience and the usability of your client user interface, which there are plenty of automated tools to do. But in terms of actually testing the meat of your application, like the exact smart contracts and all that, this is important and helpful to you that it goes through dapplib. The other thing I want to point out is that within the scope of testing, you're going to need a lot of accounts. So we pride ourselves in making that process super simple for you, and the fact that all the test accounts are auto-generated, etc. So one of the things you don't want to do is scrimp on those. You don't want to just repeat accounts, etc. In this demo that Jacob's doing, etc., the surface area isn't very large, so it's okay to test with 1 or 2 accounts. But when you are testing, it would be worthwhile to put your tests in a loop, for example, and run it for multiple accounts, an array of accounts, etc. We make it super simple for you to create accounts. If you go to rhythm.js, and there near the top is a constant. It should be somewhere. There it is. Let account count equals 5 is what it was. Scroll down a bit more on line 46. So merely by changing that to something else, so let's say make it like 8 or something, and then just reload the yarn start, the UI. You can also, by the way, right there is where you also customize the initial balance. You see it says let tokens equals 1000. If you want them to have more tokens initially, you can do that. But
these are flow tokens.
Yeah, those are flow tokens. Yeah. Merely by changing the value there, the initial balance will be there. If we go to the UI once it's up and running at this point in the web browser, and go to any of the action cards and look at the account widget, but you can already see that it's creating more accounts than. By the same token, if you're early in your development cycle, make that one, so it goes through faster. You don't have to wait. But these accounts are automatically named. So if you drop down on any of those now, you will, as soon as it comes up, you'll see that we already have a bunch of names there, and then it starts giving them friendly names. The friendly names then progress into user 7, user 8, user and so on and so forth. So all of that is something that we've taken a lot of care to write, so you can focus on the important work of building your dApp. So these are all the kind of little things. The last thing I wanted to so there's a question that is key count equals 2 for each account in Rhythm.js. So let's go look at that code. I want to make sure I answer the question accurately. Yeah, so the key count is the number of public keys added to the account. So you can add more or less if you want, but Flow accounts support basically an infinite number of public keys, and they can also have weights. So while we do handle the weights, etc., in the signing part, for the most part, it seems like all the Flow apps thus far all use the maximum weight, which is 1000. If you look on line 38 there, you can see that the service account weight is 38, and I'm sorry, is 1000, and the key ID is 0. So you can add multiple keys if you want. And that's sort of manifested in dApp config JSON. So if you go to dApp config JSON at this point, you'll see that the wallet collection has more entries. So can you go to dApp config.json, please?
Yep.
Yeah, so now we've got more addresses here, and lower down here, you can see that because we said 2 keys, each one has 2, and the algorithm for generating the keys is automatically splitting the difference. It's saying if you put 4 keys, it's going to put 2 keys at 1000 and 2 keys at 500. It just splits the difference. That's why you see 1 key is 1000, 500. That's just, when I wrote that code, I'm like, well, what would a developer want? What would I want? And I just wrote it that way. Happy to accept suggestions on that, but and you can easily add more keys, etc. And going back to a comment I made in a previous office hours, our goal is to get you started coding right away. And so this account generation stuff, key generation, etc., it is just grunt work that you would do upfront. Otherwise, we don't want you to waste your time. So that's what this is all about. The last thing I wanted to point out is when you're actually writing your unit tests, that's going to be when you have the most head scratching moments about like, wait, what is going on? And different developers are comfortable with different things. Like Jacob likes to do console log. There's nothing wrong with that. That's perfectly okay. But some other developers might like to actually look at the stack and do debug. So I wonder, Jacob, if you wouldn't mind throwing up a VS Code terminal in here and just switching to the JavaScript debug, and then putting a breakpoint maybe at line 328 here. Yep, there we go. And then run your yarn test. Yep. And you should see VS Code doing all its fun debugging stuff and allowing you to let's see what's going on here. There it's did it die?
Oh, because I forgot to.
You already have that running. Okay. Yeah.
Yep.
Yeah. So I was working on killing all other processes, and one of the only ways to do that is to use node kill, and I was afraid I would kill some other sort of app you were running in the process, and so I didn't include that code. That breakpoint is not red, so I don't know Yeah, it says it's unbound. We'll find out. It might come into scope in here in a little bit. So let's just leave it and see. And if not, we can troubleshoot that. There it is. It's in scope now. So good. It was just that script was not in scope. And so, so when it hits that, we should be able to step through the entire test. Now, one of the challenges in JavaScript programming, contemporary JavaScript programming, is when you have a lot of asynchronous code. So debugging that is a little challenging, but you can just step over some of those and should be okay.
Mm-hmm.
So hopefully we'll get to this test. Yeah, there we go. All right. So we are there now. So we can now just use the blue arrow with the circular arrow with the dot below it to step over each segment of code and look and go through it very diligently so we can identify any errors. So anytime you see an await, you wouldn't want to step into it. So you wouldn't want to use that arrow with the dot below it. That's going to take you into a rabbit hole that very hard to get out of. So just step over those. But here the nice thing is you can look at it. Now, notice that the res1 result says big number. So when you are programming and writing smart contracts, etc., you have to automatically assume that JavaScript's built-in int functions limit, which I believe is 32 bits, but I could be wrong, is not going to be enough. When you have a uint64 or uint256 and all that, that's going to blow up right away. So we use the big number library, which is standard for smart contract developers and smart contract framework developers. It's not anything novel we are doing. So big number is a great library. It just requires a little bit of caution in that whenever you use a number, every number you use has to be wrapped in a big number object. So that's my, hopefully it will save you some time. It has cost me probably, I don't know, a few days of my life when I was just saying something like, bn something plus 5. And because the 5 was not wrapped in big number, it wouldn't work. And those are sometimes hard to find and identify bugs. So just, yeah, you can step through this and go on. But I wanted to make sure that everyone was aware that while, the client-side code that's running, because it's web-packed, etc., it's a little harder to do debug like this. The test scripts where you really need it are great. And so this is another reason why you want to actually start with unit tests, because you can immediately start debugging your daplib code and don't wait till the end. So, I posted in the Discord that we use the arrange act assert pattern. Test-driven development used to be a big thing. It is no longer there, but in smart contract development, one could make a case that it would be interesting to start writing a test and have it fail and then keep adding to daplib and your smart contract until it passes. So that would be an approach for you to consider. So
yeah. And I also wanted to make a few comments about testing, not about the app starter tests, but more about how do you test your smart contracts in Cadence? And maybe some of you are wondering, well, what should I be looking for? And Nick made a great point earlier where, a lot of your testing when it comes to stuff like this is edge cases, right? And so on Flow, that really, turns out to be, well, okay, let's say we have a smart contract and, on Monday, we went over access modifiers with access contract and access all and access account. Well, one of the tests that you really want to, test for with an edge case is, try and run a transaction, try and run a script that, tries to break those things. And let's say in your contract, you have some sort of access modifier where, you only want to expose it to the contract, or you only want to expose it to an admin account. Try and run tests where a user, accesses that, whatever it may be. Maybe it's a resource, maybe it's a struct. Try and manipulate the data. Even if you just have a field in your contract, let's go up to our contracts and go into Kibble, right? Let's say sorry, I scrolled fast, but let's say at the very top, we have a total supply called, ufix64. even though we can't because it's pub, try and run tests where you're modifying this total supply outside the contract. Try and think like a hacker and break this kind of stuff. And the other suggestion I would give is if you're linking storage paths to the public with capabilities, try and run transactions and scripts where you're reading into capabilities that you shouldn't be reading into, or whatever it may be. Just try and break capabilities, try and break account storage, break your access modifiers. And if you can, well, then obviously there's an issue and you go back and fix it. But I just wanted to make a quick comment on what you should be looking for in your tests. So I think we also have some general questions about the Flow CLI from some participants in the Zoom. Feel free to ask away. I'm opening up to not DAppSoda related.
Hi.
Hi.
So yeah, it was great. Like I have followed a 1 week of the bootcamp, and second week I'm struggling a bit to follow. So yeah, I've worked around like uh, executing the tutorials which I've learned from Cadence, uh, NFT tutorial, and through flow playground I was able to mint and transfer tokens. I wanted to see like how can I make sure to run it through flow CLI, and I want to make a like independent code uh, so that any language can run that code. Like, basically, you consider Python, like I just want to make some remote procedure calls, RPC calls, and it should work. Like the basic core functionality should work. So I was thinking that way. Can how can we make sure it is done? So
Sorry, do you mind repeating your question? It's we're speaking a little louder.
Yeah, it's sorry, sorry. It's basic question like how could we make sure like to use Flow CLI, okay, to run any to run any programming language. Like consider not JavaScript, but like consider Python or different any languages.
Yeah, that's a great question. So the Flow team, let's actually do this together. Let's go to the OnFlow GitHub page and we'll click here. They have, if we scroll down, you'll see they have this Flow.js SDK.
Yeah.
This is for JavaScript. The other one is Go. As of right now, I don't think they support things like Python or other languages like that. But if you know Go, then they do have this option here, the Go SDK.
But like through Flow CLI, we can make sure that we can implement the core functionality which I have developed. Like I run some code CLI code where I can mint and transfer token. So can we use this command line Flow CLI to like make a remote procedure call? Like okay, I have a function in Python which calls Flow CLI and does my work. Like, so I was thinking in that way, or how to like do we have to build an entire SDK, or like
yeah, it's a great question. Yeah, it's a really good question. To be very honest with you, I don't have much experience with trying to do that. You could always ask in the Flow Discord, specifically Max. If sometimes you'll see him online, he might be able to answer some questions about that. But I haven't tried myself. I know that I think Morgan, who was teaching you during week 1, actually attempted to make his own SDK.
yeah. That's what, like making his own SDK, or like having a control over all the things going on. What is actually going on here?
Yeah, no, you could definitely attempt that. I mean, it would it might be a bit of a brain teaser, but I think yeah, I mean, you could definitely go for it. I don't have much experience with that, but maybe even ask Morgan about it because he's done it before. But yeah, I'm not entirely sure. Besides the Go and JavaScript SDKs.
Yeah, I think Flow, Go and JavaScript are pretty well defined, and like the FCL. If you talk about FCL is one of the best like built up by Flow team. So I just want to make sure that how could I leverage that to some other platform which we'll be working on. So that's what I was thinking about it. Okay, thank you.
Yeah, no, it's a great question.
I'll reach out to Morgan and other one. Who is the other one in the team?
Maybe was it Nick?
Nick. Okay, sure.
Yeah, no, it's yeah. Thank you for asking that. It's a great question. And honestly, maybe I'll look into that a bit and let you know.
Yeah, what I'll do is I'll share you my flow CRI commands where I did it, and I basically share your thing like core structure. Just let me know if it's right or wrong.
Yeah, I will. Sure.
Thank you, thank you.
Yeah, of course. Oh, BZ says thank you for adding subtitles to the YouTube videos. Oh, BZ, I don't think that was me. I tried to figure it out and I couldn't. So it must have been someone else. It might have been Nick actually. Oh, I see Nick already left the Zoom. But yeah, so this concludes the Decentology office hours for week 2, day 4. Thank you as always for coming in with your questions. And as always, if you have any other questions, just please feel free to ask in the burning questions channel. But we've concluded the day 4 quest. Day 5 content will be coming out soon. It's not going to be that much at all. It's actually relatively small, but there'll be a fun quest to do. And with that, we'll maybe wrap things up there unless anyone else has any questions.